Illusionists invented relativity 15 years before Einstein. That's right. It's historically accurate to say that Einstein merely finished relativity, but the central calculation that defines everything you know about relativity was created 15 years earlier by illusionists, and I'll provide the proof for that as we progress through our historical overview. Along the way, I'll grant you an intuitive understanding of relativity completely lost to modern audiences. So first, what many people don't realize is that, for thousands of years, there was no difference between a magician and a scientist. The razor-thin line between illusionist and natural philosopher, right up to the 19th century, was only an attitude of hiding versus sharing, the knowledge they learned of the physical world. Each deeply desired to uncover and master the hidden truths of the world, and the word occult simply refers to that which is hidden. To accomplish this mastery, one must truly comprehend evidence and experiment, and most importantly, how humans experience and interpret it. To find truth, one must utterly master illusion and falsehood to be able to separate it from said truth. The process of removing impurity in the practice of alchemy was well understood to be a metaphor for the practice of removing falsehood during that process of truth-seeking which gave birth to modern science. Understanding the long history of focus on illusion and falsehood is critical to a more robust understanding of how and why relativity was invented, and indeed how science itself eventually emerged. For instance, while we can only speculate that all the engineers for the pyramids were thought of as magicians, we have adequate records from a little before the Common Era that the Pythagoreans were a mystical order who guarded secrets of divine geometry and the harmony of the spheres, with a death penalty for sharing those secrets because knowledge of truth grants power. Today, we think of their magic as nothing more than geometry and consequences of wave mechanics combined with some basic astronomy, but their secrets still move the modern world. Pythagoreanism influenced all the Greek philosophers, and it could be said that their search for magic was the beginning of Western science and philosophy. Plato's school, for instance, as a legacy of the Pythagorean cult, had the axiom, "Let no one ignorant of geometry enter," emblazoned above the entrance. In 415 AD, Hypatia of Alexandria was a well-known astronomer and mathematician murdered for the use of magic and astrolabes, and is held as one of the very first martyrs for natural philosophy. In the 1500s, John Dee, Queen Elizabeth's advisor, mathematician and astronomer who greatly advanced the art of navigation, was directly referred to as a magician and accused of demonology. In the 1600s, Johannes Kepler applied Pythagorean occultism and their musical view of the universe to develop his three laws of planetary motion. In the 17 to 1800s, Sir Isaac Newton, the most influential scientist in history, was not only an avid alchemist, but deeply entrenched in the general study of the occult. From ancient times to modern, it was always the same archetype of person, obsessed with comprehending reality, whose obsession itself was the requirement to produce illusions and deceptions of the senses. In the 1500s, Leonardo da Vinci created the first workable mechanical automaton that could sit, wave its arms, and move its jaw. During the 1700s, creating lifelike illusions became a sensation, with one of the most famous examples being the silver swan, which is an automaton that preens and catches mechanical fish. It does it all in an extremely smooth and surprisingly lifelike manner, set to music that it also simultaneously creates. The Mechanical Turk was a chess-playing robot that toured the world in the 1700s, but secretly hid a small chess master in the table below the board who could manipulate the automaton to move chess pieces via intricate mechanical devices. In each case, an obsessive dedication to comprehending the intricacies of the real world and its mechanical nature was required to separate human perception from underlying reality. We wouldn't refer to early illusions as smoke and mirrors without the fact that natural philosophers were all fixated on light and its manipulation, and so it is no coincidence that mirrors also pervaded all aspects of the occult since ancient times, and specifically played a crucial role in alchemy. Finally, one of the most famous and influential illusions of all time was Pepper's ghost, which was invented in 1862 during the heyday of optical science. It is still widely employed today to project deceased artists on stage in concerts, and it is often falsely referred to as a hologram. It is especially notable in our narrative that this particular mirror illusion with light would have reached a height of popularity right around the time that relativity was first conceived in 1889. These environmental influences grant us key insights into the scientific minds that lived in the transitional period in which relativity was developed. Every single scientist of that time period deeply and intuitively understood the intricacies and complexities of how to perform illusions and therefore debunk charlatans. Finally, they also understood that nature itself creates its own illusions as well. While superstitious people would have once believed that a mirage was the work of a jinn or a pernicious god that meant to tease the thirsty with a false promise of water, such apparent magic always drew the attention of the scientific mind. Therefore, the behavior of light was the core of 19th century science, which gave birth to the modern world. Like the mirage, there is another automatic illusion performed by nature that every single scientist of that era would have known very well, but that you almost certainly have never even heard of. We must make sure you completely understand this particular little-known illusion so that you can understand why illusionists invented the least-known illusion of them all, relativity. First, however, we'll need to avoid a common confusion about our next subject, the Doppler effect. While Christian Doppler proposed the Doppler effect for light in 1842, in 1845, the Doppler effect was empirically tested and confirmed via sound experiments. It is absolutely critical that, if you know anything about relativity, you remember that relativity does not apply to sound, even though Doppler applies to both light and sound. For example, for light to behave according to the modern interpretation of relativity, it is mathematically necessary that every moment be four-dimensional. Sound only requires 3 dimensions. This differentiation between the mechanical workings of sound and modern ideas of light did not exist until after the illusion at the heart of relativity that this film is addressing. Put in simpler terms, classical waves were understood as something that couldn't exist on their own. Remove the water and ocean waves cease to exist. Waves are an action occurring to something else. The wave only exists as a notably active portion of some substance or set of things. Classical waves, put simply, are just a consequence of particles of a substance bunching up and spreading out. A disturbance from and return to an equalization of stresses between parts. It's a little like entering a crowded elevator in that everyone slowly adjusts to try to balance the space. Because it takes time before a neighbor reacts, there is overshoot, and because there's overshoot, there is backfill. That's all a wave is. Displacement from equilibrium, non-instant reactions, return towards equilibrium and overshoot. Disturbance, lag time, and movement towards least resistance. What the medium's properties are, where it is, and what it's doing, completely defines the waves and flows moving through it. A wave is nothing more than what sections of a substance are doing, a verb, not a noun. Only by understanding this fact can you really understand the specific illusion we are about to discuss. It is an effect that even physicists are rarely aware occurs in sound if they haven't thought it out. Let's quickly review the salient facts of the Doppler effect. The characteristic change in frequency can be caused by 2 different mechanisms. First, by moving the emitter through the medium, and second, by moving the listener. Let's say you're in an ambulance. Waves emitted from a moving emitter are squashed in the direction of travel because the wave only travels at a given speed within its medium, air in this case. So even though you're creating the same number of waves per second, the ones going in the same direction can't get away the normal distance before you create another wave, and they get stacked up this way. The ones moving away from the emitter also have to travel away from the point of emission at a speed determined by the stationary medium. So even though your emitter creates pulses at the same timing, you've run away from waves going backwards, so you added your motion to the distance between waves, and this causes them to be spread out. This effect occurs no matter how the difference between the emitter and the medium is created. If there's simply a strong wind, the waves get stacked up and stretched out by the same mechanism. The illusion, however, is this. Place 2 people on a flatbed truck in open air, and no matter how fast the truck carries them through the air, they will hear no Doppler effect so long as they are moving together. Why is that surprising? Because we know that the waves going in one direction are physically different from the waves traveling the other direction. People on the ground will certainly hear the Doppler effect in the voices of the people passing by, but the people moving together cannot detect it at all. If we ignore things like turbulence, there's no clever experiment they can perform on the back of a moving truck which will reveal the frequency shift we associate with Doppler effect, even though it is certainly happening in reality. The waves truly are beaten into the air in physically different ways depending on the direction of travel. The issue, however, is that there is a second method, where the wave size stays the same, but the listener can run into or away from the waves to change the perceived frequency. The two effects can be combined in an opposing manner to create an exact cancellation and thus produce our illusion. It's simply that a perfect compensation automatically occurs. What is gained by motion at the emitter is lost via motion at the listener. For instance, looking upwind. Even though waves are actually bunched up and have shorter physical length between them, the listener is actually moving away from them, so they are playing catch-up, arriving at a slower pace, no matter how close together they are in the air. Each peak has a longer delay between their arrival, which perfectly lowers the frequency it was raised for people hearing it on the ground as they passed. Furthermore, if they move around on the truck, the only Doppler they will detect is the motion between them, not their full motion through the air. It is this strangely automatic and perfect compensation that hides the fact that the waves physically exist in different shapes, but the co-moving observers cannot detect the fundamental truth of this very real alteration. We know it is an objective truth that the Doppler effect is occurring, even though the illusion hides it, because we know that sound waves do not exist without air any more than ocean waves exist without water. We know waves aren't independently real, so we can separate truth of their relative size from the false equivalence of the subjective experience. And as a good illusionist and good scientist, we can separate fact from fiction, even when experiment cannot. The consistency and convenience of the observer's perspective is completely irrelevant. The experimental replicability of it is irrelevant. Subjective experience, even subjective experience of instruments, is irrelevant. Humans and instruments alike can experience perspective illusions. It is in the infinite causal depth of events and the unbroken mechanical interlocking of them that we separate superstitious thinking from rational. An illusionist knows that perspective is the heart of illusion, and only a fool believes his perspective trumps underlying reality. This hierarchy of objective reality placed above personal perspective is the separation of magic from science. Every charlatan shows us a test of reality that seems to prove something. Causal consistency, however, not bare empiricism, is what first separated science from superstition. Every superstitious person has mountains of evidence for their beliefs, but it is the process of identifying the interlocking nature of reality that reveals what lies under our many illusions and separates out the dross. This mechanics first ideology, hard won over the thousands of years of search for magic, is what brought humanity from the caves with the light of science. Mechanical reasoning is the beating heart of scientific pursuit that weeded out faulty interpretations of experiment. Magic is causally inconsistent, but science is a perfect interlocking causal machine. This mechanism of a compensatory illusion you just learned about in the Doppler effect will now lead you to independently discover relativity yourself in just a moment. Let's now embark on the final leg of our journey as we create a devious extension to the Doppler illusion we just described. Let's imagine that I had some friends who ran some experiments on one of those open trucks to try to pierce the Doppler illusion. And in the process, they discovered a way they could at least detect their motion through the air using sound, even though they couldn't detect the change to the sound. They had placed a small plate 10 feet forward from a speaker at the back of the truck and another plate 10 feet out to the side of the truck. The speaker emits a single short chirp. Using a microphone just above the speaker, they listen for the reflections of the chirp that come from those plates. It turns out the echoes will always be different in timing by a certain amount that depends on the speed of the truck. Because they know the angles and distances the sound would have to travel through stationary air as the experiment moves through it, they can calculate the exact speed of the truck. They simply did a little calculation and discovered that while the forward plate runs away from the sound and the reflection slams quickly back into the oncoming microphone, the total amount of air the sound traverses is always greater than if the experiment was stationary. The path the sound must take out to the side, however, is very different in that it has to travel out at an angle and back to catch the moving microphone. While being longer than the stationary path, it's shorter than the path along the wind. Given that my friends are also good Platonic philosophers and scientists, they did a little geometry and figured out that regardless of the speed, the path out to the side and back would always be the square root of the path along the wind. They also found that there was a relationship between the speed of the wave and the speed of the experiment that always related to a specific angle, and that difference always leads to a certain amount of growth in the path length across the wind. It's a geometric formula. Pythagoras would be so proud of them. But we, my friend, are illusionists and can use their work against them. To create yet another compensatory illusion in this experiment, We merely need to invent a material which shortens in response to wind passing across it in the squared relationship they already identified. We could make sure they are only allowed to use this reactive material to construct their experiment. Then, just like the Doppler illusion, no matter the speed of the experiment, the chirps would always return at exactly the same time by eliminating the difference in distance. To put it as George Fitzgerald did in 1889, we'd need to shorten the experiment by an amount depending on the square of the ratio of their velocity to that of the wave. While it turns out one must take Fitzgerald's relationship, subtract it from 1, and then find the square root of that for the final calculation, he had described the root of the illusion. There you have it. Shortening perfectly compensates for all speeds of the truck, making both of the very different paths exactly equal in time and path length through the air. Our sound experiment is an exact analog of the Michelson-Morley experiment, which was the entire impetus for relativity. Now we can see how the core principle of relativity, the factor of change, was invented by illusionists 15 years before Einstein. But our story doesn't end there. Let's dive deeper into how this illusion relates to our modern understanding of relativity. Now, you might be wondering, how does this relate to light and Einstein's work? Well, here's where it gets really interesting. The Lorentz-Poincaré ether theory, which preceded Einstein's relativity, treated light as a mechanical wave, just like sound. This might seem counterintuitive to our modern sensibilities, but it's crucial to grasp this perspective to see how the illusion of constancy and the speed of light shaped modern theory. Poincaré's mechanical relativity is historically described as mathematically equivalent to Einstein's relativity. But those two interpretations still describe completely different versions of the world. In this original view, light is just a mechanical wave traveling through the medium of space called the ether, just as sound propagates through air. The key insight of Fitzgerald, and later Lorentz, was that if matter itself contracted in the direction of motion through this ether, it would create an illusion of constancy in the speed of light, just as our imaginary material created an illusion of constancy in the speed of sound. This formula is the exact basis for what we now know as the Lorentz transformations, which are at the heart of special relativity. A formula that is a mathematical description of our illusion. You must remember, however, constancy in light is nothing like what the word seems. It's a solipsistic perspective where waves always propagate according to your personal experience. Constancy is the belief that whatever speed you go, light propagates with you. We had to add another dimension to allow all the conflicting perspectives to be true simultaneously. If the inventors of the formula were right, however, then just like our illusion with the truck, the Michelson-Morley experiment simply fooled people into believing that a wave always behaves the same regardless what the medium or emitter is doing. Because we know a wave is an action and not an independent object, however, we cannot be fooled by the illusion into believing all perspectives are equal. Einstein's genius was in recognizing that if this contraction was real and universal, we could ignore ether altogether and greatly simplify the difficult calculations of Lorentz by merely treating the constancy of the speed of light as fundamental. He gave us a shortcut that allowed us to calculate electromagnetism much faster and easier. Simply act as though the topical illusion is truth and ignore the underlying mechanics the math refers to. But here's the kicker. In the Lorentz-Poincaré view, time dilation and length contraction are real physical consequences caused by motion through the ether. The constancy of the speed of light may be just an illusion, but one correlated with real, measurable consequences according to the precursor theory. The mechanism that underlies the constancy effect is not just a mathematical trick or a quirk of measurement. It's a fundamental aspect of how matter interacts with the medium through which light propagates. It shortens. In the precursor theory, the apparent constancy of light is a symptom of a deeper mechanical truth. The constancy we observe is like the woman sawn in half, but the deeper truth is that we experience this amazing thing because real mechanical devices are doing something very particular. Now you might be thinking, but hasn't this ether theory been disproven? The answer is no. Only old versions of ether were ruled out, not this relativistic one we're talking about. The mathematics of the Lorentz-Poincaré ether theory are identical to those of special relativity in the overwhelming majority of situations. The key difference lies in the interpretation and the underlying physical model. Einstein and Minkowski's approach, which we typically learn in school, treats the constancy of the speed of light, the illusion, as a fundamental principle and ignores ether, the causal mechanism of it. The Lorentz-Poincaré view, on the other hand, retains a preferred frame and treats constancy as a perspective illusion created by the interaction between matter and the substance of space. You might wonder why we don't hear more about this alternative interpretation. Well, for most practical purposes, both theories make the same predictions. That was the beauty of Einstein's simplification. However, there are some edge case situations where they diverge, and this is where things get really interesting. Experiments like the Sagnac effect, the results of the Harfili-Keating experiment, and observations of the anisotropy in the cosmic microwave background radiation all suggest some form of preferred frame, something that aligns more closely with the precursor ether theory than with the conventional interpretation of special relativity. Even more surprisingly, general relativity itself, Einstein's crowning achievement, introduces concepts that are more compatible with an ether-like substrate than with the etherless view of special relativity. Minkowski's space-time that Einstein eventually used in general relativity behaves in many ways like a physical medium, but is fundamentally different. It allows the physical impossibility perceived in the illusion to occur by adding more space to reality, which can accommodate 3D conflicts via adding the fourth dimension. Einstein famously quipped about space-time when it was first introduced. "Since the mathematicians have invaded the theory of relativity, I do not understand it myself anymore." But when his mentor Minkowski suddenly dropped dead shortly after his snide remark, he found a way to use the mathematical formalism. It's worth noting that even Einstein himself, after a few years of consideration, came to believe that some form of light-bearing medium was absolutely necessary for his theories to make sense. Just 5 years after he published his opus on gravity, he wrote an entire lecture explaining the necessity of ether. That 1920 lecture can be summed up with the following quote: "According to the general theory of relativity, space without ether is unthinkable. For in such space, there not only would be no propagation of light, but also no possibility of existence for standards of space and time." Strangely, only a few historians are aware that Einstein denounced constancy as incompatible with his finished general theory on at least 5 different recorded occasions. And other renowned fathers of physics also called for a return of the ether as the field continued to progress. In 1951, Paul Dirac published a paper on the ether he summed up with the following: "This motion's physical significance in the theory is that if there is any electric charge, it must flow with this velocity. And in regions where there is no charge, it is the velocity with which a small charge would have to flow if it were introduced. We now have the velocity at all points of space-time, playing a fundamental part in electrodynamics. It is natural to regard it as the velocity of some real physical thing. Thus, with the new theory of electrodynamics, we are rather forced to have an ether." In the 80s and 90s, John Stuart Bell gave numerous statements advocating for ether, saying, for instance, "I would say that the cheapest resolution is something like going back to relativity as it was before Einstein, when people like Lorentz and Poincaré thought that there was an ether, a preferred frame of reference, but that our measuring instruments were distorted by motion in such a way that we could not detect motion through the ether." Now, you might be wondering, if this alternative view has merit, why isn't it more widely known or accepted? Well, that's where the history of science and the nature of paradigm shifts come into play. Thomas Kuhn's famous work, The Structure of Scientific Revolutions, discussed how difficult it can be for new ideas to replace established paradigms, even when evidence favors them. It's a problem so well known there's a name for it: Planck's principle. Paraphrased, science progresses one funeral at a time. The shift from the many additional calculations required for relativistic ether theory to Einstein's shortcut was so appealing, and Einstein's formulation so mathematically elegant, that physics as a field was reluctant to look back. The more concise formulation reduced manual calculation overhead and made forward scientific progress easier. Relativistic ether never caught on because the work was hard enough without the extra considerations it brings. They asked themselves, why look backwards? And the ether became synonymous with outdated thinking, despite the fact that the Lorentz-Poincaré formulation had no evidence against it. No one ever suspected that all the additional underlying mechanics would ever, one day, grant additional insights, so it was forgotten for a century. But here's the most important takeaway. Whether you prefer the Einstein-Minkowski view or the Lorentz-Poincaré view, the fundamental effects of relativity time dilation and length contraction are real observable phenomena. The only debate is about the underlying cause and interpretation, not the effects themselves. These effects aren't just abstract concepts, from the design of particle accelerators to the need to account for time dilation in GPS satellites. The universe really does behave this way, regardless of how we choose to interpret it. The only question is if all the additional underlying mechanics of ether grant us any additional insights. Will the additional information allow us to manipulate space? We're finding that with the many crises cropping up all throughout modern physics, the calls for revolution are being answered with hydrodynamic space we used to just call ether. We'll have to save exactly how the ether paves the way into the future for a different video, and so we come full circle. Just as the illusionists of old sought to understand the fundamental nature of reality by mastering deception, modern physics grapples with the possibility that what we perceive as the fundamental constants of nature might themselves be a kind of cosmic illusion, a perfect compensation that hides a deeper reality. The next time you see a magic trick, remember, you're not just watching an illusion. You're witnessing the roots of curiosity that culminated in a tradition that has driven scientific inquiry for millennia. A tradition that gave birth to relativity itself and continues to shape our understanding of the universe to this day. And who knows, perhaps the next great breakthrough in physics will come not from a laboratory, but from someone who understands that to reveal the truth, you must first master that which is hidden.